Inventing a digital currency the Bitcoin way. Welcome to another video. My name is Kugi, and in this series I will try to give insights on Bitcoin technology in an easy to understand way so that more people know how this great technology works and what's the driving pillars beneath it. Today we start this off with the fundamentals or the building blocks of Bitcoin, and I try to kind of derive it from the way a currency works and how to use it so that it might be easier to understand how this is done. First disclaimer, this is how I understand it and how I see it. Might not be 100% correct. Always do your own research. This is, of course, no financial advice. In this series, I don't want to talk about any financial topics, just the technology and how the stuff work, so that you have a better understanding of how the stuff fits together. If there are any comments, any things I got wrong or where it's not clear, feel free to comment. I won't go into all the technical details and leave some stuff out because if you go into all the details, it honestly is or could be quite confusing. So I will try to keep it on a high level. If you understand more on this, good for you. But then likely this video is not for you. First, I will go a bit into basically the basic topics of money, not the whole invention of money and everything, but how banknotes came about, and then we will dive directly or move on to getting the stuff digital. Digital, trustless, decentralized, as Bitcoin is and as it should be. So first, let's hit it off. In the beginning, there are coins. Now, not yet talking about Bitcoin, but just as a currency. Coins, gold coins being exchanged for goods and anything. After some time, with coins being heavy and sometimes having some issues in practical use, banks started to give notes out. So in the end, basically it means people put coins into the bank and get a piece of paper that says this is worth that amount of coins, and if you go to the bank and give that paper to the bank, they give you the coins out. Bit more to it, but that's a rough idea of how banknotes got created. And now someone has this banknote worth of coins. And after some time, instead of just get the coins and then trade the coins for goods and services, people started using those notes. But how to use the notes if you want to pay something less. So we have Alice. Alice has a banknote worth of 50 coins, and Alice wants to pay 5 coins to Bob. What can Alice do? I mean, if you use cash, you know how it goes in our current system, because Alice gives Bob the note of 50 coins, and Bob returns Alice a note worth of 45 coins. In our current system, we have different notes with different values, and you just put up some notes together, right? The problem with this, if you want to put this into a digital, or this concept into a digital way, and basically in a trustless digital way, how do you know that Bob will give you back notes worth 45 coins? Even in our society now, if you go to a shop and pay something worth $5 with a $50 note, you have to trust the guy on the other side of the counter to give you back $45, because you give them the note, and if they are not trustworthy, if they are trying to scam you, they take the $50 and run. And then you lost your money, because you have to trust them. Usually it's in a shop and it's all happening, or sometimes if you don't trust them, you hold your $50 until they give you the change, and then you directly exchange it without letting go of your $50. But that's the problem with the trust issue, with having this trustless on internet. And if you think about this in a digital way now, you need to somehow send this note of 50 coins to Bob, and then have in the second step getting the change back, which is in a digital way might be asynchronously, so you can't sit there and wait for the others. If you want to send something to someone, you can't wait for the other to sign it and have everything set up, but you want some way of being able to do that, decentralized, asynchronously, and trustless. So what can you do? What is a way is to say you go back, still in the not digital way, you go back to the bank and give them back the note worth of 50 coins, but instead of taking out the coins, you just request from them a note worth of 5 coins and a note worth of 45 coins. Now you can pay, Alice can pay, or give Bob the note worth of 5 coins and keep the 45 coins note. And it's done. And this, in a thinking decentralized way, this can be done by Alice without asking anyone else beside the bank. So the bank as a central system is not necessary in this banknote scenario, but it doesn't need Bob. Alice doesn't need to wait for anything. Alice just goes there, exchanges, splits its note into 2 notes, and then sends one to Bob and keeps the other. So that's a bit the building blocks of the stuff that we now want to think about. Now moving this into a digital world, or into a more transaction-based idea. Let's look at what this economy, or some sample transactions in such an economy. So building blocks we have is there are notes, bank notes, representing values, representing coins, and you can split the coins and you can transfer stuff. First thing, again, we start with an economy of 4 people: Alice, Bob, Caesar, and Doris, A, B, C, D. Alice starts with a note worth of 50 coins. Caesar starts with a note worth of 50 coins. Bob and Doris have nothing. Where the coins come from is honestly a different topic. I might make a video about this in a Bitcoin way, but I don't want to get too overboard in the first video. So today, just about how the thing continues. First transactions, Alice wants to send those 5 coins to Bob. We already know Alice can split the coins. So what Alice does is splits the coins to this node into a 45 coins node, which stays in her account, and the 5 coin node goes there. On the other side, Caesar already also does similar transactions, sending 10 coins to Doris, splits his 50 coins node into a 40 coins and a 10 coins node. And now we have those amounts. Let's look at another one, a bit more in one transaction, because Caesar says he wants to send 7 coins to Bob, 15 coins to Alice, and keep the change. Again, his 40 coin node, what he now has, is split up into 50, 7, 18 coins, and distributed and sent to those addresses, to those accounts of the people. Now Alice basically has 45 coins node plus a 15 coin node. Bob has 12 coins, 5 plus 7, and Caesar still has 18, and Doris has 10. Now let's have a bit more complicated thing. Bob sends 10 coins to Caesar. So Bob wants to send this a 10 coin note here. Bob doesn't have any note that's bigger than 10 coins. So what he has to do is he combines this node and this node and got 12 nodes, and the remaining change stays in his account, and the 10 coin node goes there. So it's basically, with the think about a bank, he takes the 5 and the 7 coin node, goes to the bank, says, here are those nodes, give me a 10 and a 2. And since they are both his nodes, he can just do that without asking anyone except for the bank, and split that up and send it. Now, one important thing to note here is, for us, since we use banknotes and everything, it's obvious, but if you design a digital currency, it's an really important topic, and that's the question of double spend. Because, for example, Alice already used the 50 coins note here to split it into a 45 and a 5 coin. Basically what we had here about give it to the bank destroys this node and exchanges for this one. So this node is no longer spendable. It's an already spent node and can't be double spent, because if you now just think about a digital system which just send messages around saying I'm doing that, and no one keeps track of that, you might be able to trick the system. But that's important to not be able. So you kind of need to keep track of what nodes have already been removed. And that's all the nodes that have been spent, because they already are used in some transaction in some way. First thing. Second thing to note is what we see here is a graph being nodes and connections between the nodes, so edges, and they are directed. So we have always a direction, in this case from left to right. So it's a time-wise connection, but you don't need to think about it in time. It's just a direction from one node to the next. And there are no cycles, so no loops. You can't have it that this coin is spent and creates this node. It's never going back in the spending hierarchy, in the spending order. So what we called it in the theory and in the research and everything, it's called a directed acyclic graph. So if you ever come across this term, DAG, that's what this means. It's just a system where you have connected things, where the connections have a direction, and there are no loops, because it all moves forward, but you might have them split, you might have them combined, so multiples 1 to multiple, or multiples, so those two to 1, but doesn't matter. The important thing is no cycles and directed. Now, having this in mind, to say, okay, that's how the nodes move, we split it, everything pretty clear. Let's look at, I colored here all the actions that are done when one spending transaction, and let's really call that a transaction. And that's how we can formulate such a transaction. So this is, for example, this last transaction that's splitting the stuff. A transaction has inputs. It's a list of nodes in our case. So the bank nodes are the inputs. And it has a list of outputs. That's the resulting nodes. Important is that this transaction needs to be signed by Bob, because Bob owns the inputs. So actually it need to be signed by all owners of the inputs, because if we now say this happens, those two nodes should be used for this transaction, the owner of the nodes need to be there. In our bank, with the bank, it would be you have to be there and confirm, yes, I want to split this node, because you own the node, this bank node. In this case, it's not tied to you. In cash case, it's if you give the $50 note to someone else, they own the node, the bank node. But in the digital way, this transfer always means give it to a new owner, and the owner needs to verify and sign that they want to do that with those nodes now. So a transaction needs to be signed by the owner, all the owners of all the inputs. And the sum of the inputs needs to be the sum of the outputs, because you can't spend more than it goes in. But that's it. C is actually not involved in this transaction with signing or anything, because you can give money to anyone without asking them, basically. So C is not involved here, it's just inputs and outputs. And that's the building block of the transaction. So that's a transaction already in our digital currency, a digital transaction signed. Again, not going into details about the signing here, just enough to say or keep in mind, there is a way, cryptographically, a way to sign that B can sign this, and anyone can verify that B signed this transaction and said this transaction is okay, it's fine, I want that, and prove basically that this is done by B, so by Bob, without anyone else being able to sign other transactions. So this is the cryptographic stuff. That's why we call Bitcoin a cryptographic currency. It's crypto stuff. That's all the crypto about, because it's cryptographically signed and everything. So if we now say this is a transaction, let's look at this stuff that we did here as a list of such transactions. So we have first our first two transactions from Alice and from Caesar, the 50 nodes, 50 coins going. So we have the 50 coins. For now, ignore where they come from. They are just there as an input, and signed by A with the 50 coins going into 45 coins and 5 coins to A and B. C goes 50 to 40 and 10. Then we have transaction 3, which is the split into the 3 ones. From C, change goes back to C, and then we have 7 and 15 to A and B. And then the last one, which is combining those two and sending them 2 coins back to B and 10 to C. This one is signed by B, this is signed by C, C and A. And this is again directed as we have it, directed as a click graph. See, transaction is now a node in this graph, and transactions are connected by outputs to inputs, because as we had here, that we said, okay, banknotes and can then be spent. So the resulting banknotes of one transaction can then be used in a different transaction. And then they are used because they are changed into a new one. Now moving to the transactions, we actually have a banknote being an output of a transaction. So we have always transactions, and transactions have outputs. And any input of a transaction needs to be an output of a previous transactions. Previous, again, you can think a bit of it in a timely manner, but in a digital way, it's just there is a sorted order how these transactions are processed. It's a ledger, just one after the other. And it just needs to be that this transaction is done before this transaction, because then this input is the use of this previous transaction output. And those two transactions are independent of each other. And so it kind of doesn't matter if this is done before this or the other way around. But in a digital system, you always have some kind of definition of the order. So again, we always have this here. But again here, this is actually just a directed acyclic graph of transactions. And we have again this thing of spend, no way of double spending, because if one coin, one output is used in a new transaction as an input, it cannot or must not be used again. And that's part of what makes a transaction valid. And now we have this one of the most important terms in Bitcoin, and based on what I got from feedback from people, if they know what this term means or not. Most of them don't. If you look at this thing is an unspent output of a transaction, or in the other way, an unspent transaction output. Those are those unspent transaction outputs. And if we shortcut that, U for unspent, TX for transaction output, O, UTXO. And that's where the name UTXO model and everything comes from. That's UTXO, what you hear in a lot of discussions about Bitcoin. Yeah, it's just unspent transaction output. If you have a transaction outputs, and if you spend it, it can no longer be used, so it's no longer in your balance. And all the unspent transaction outputs are the things that make up the balance. In the case of A, this is the unspent transaction output of A. And in B, after transaction 1, this was part of the UTXOs. Then it was used, and now it's only the 2 coins at the B address. So with that, you now know what UTXO means and why it's important for Bitcoin. Yeah, that's basically already everything you need to know to understand how payments or anything in Bitcoin works. If you want to send coins, you create a transaction with inputs, some of your UTXOs, sign it, and the outputs are either to change address, either back to yourself, and the amount that you want to send goes to a different address, and this creates a UTXO for account C, and the coin changes back to you. So then they have coins in their UTXO balance, and that's what Bitcoin balance is about. Now, the topic is, some might wonder, I talked about transactions directed acyclic graphs, UTXOs and everything, but Bitcoin is a blockchain, right? There are no blocks. I didn't say anything about blocks yet. So let's come to that. Blockchain is a chain of blocks. And the big question is, back to the transactions. The big question is here, how do you broadcast it? How to tell others that this transaction happened? We don't want any trusted system or anything, any central point to ask about all the transactions, anyone to keep the ledger of what transaction happened. So how do you tell the world that A just changed their 50 UTXO to a 45 in A and a 5 in B, so that B can then use it? Because C needs to know that those are valid, those are real UTXOs, and therefore it works. And that is done via the blockchain technology in a decentralized network. Don't want to go into the whole decentralized topic too deep, because video is long enough already. Might be topic for a next video. If you're interested in that, leave a comment what the next video should be about. But just to have a quick thing about that, the blockchain is, as I said, a chain of blocks, and a block is nothing else but a list of transactions and one special transaction, which is a coin-based transaction. Coin-based transaction is creating new coins, which is an incentive for the miner, that they do the blocks, and they create a block and broadcast this block to the whole network. So Bitcoin is actually a network of nodes that run the same consensus algorithm, meaning they have a common logic of what transactions are okay, how they have to be, and how a block should look like so that it works. And that replaces, and that's the last thing that was the problem in our concept regarding decentralized and trustless, this bank that tells you to split the coin and the nodes and everything. And this bank, in our digital way of currency, is the consensus algorithm. It's a definition, a logic definition that's in source code. That's the Bitcoin core definition that says this is what is possible and what is allowed and what's valid. And everyone who takes this source code and this logic definition can verify all the blocks coming through the network and verify that the transactions in there are valid. And if I run, and if anyone runs this software and verifies all the blocks in the chain, it's because it's a network, everyone in the network keeps a copy of all the blocks that happened till now of the longest chain that's there. And if you connect to the network, you receive all the blocks, you download all the blocks that are there right now. You can verify from the Genesis block. So the first block ever created, the Genesis block, had only a Coinbase transaction, creating new nodes, and first singular UTXO, and then every new block added an UTXO. So that's one thing. One quick note about the creating of new coins. That's in the Coinbase transaction, special transaction in the block, defined in the logic how big this newly created amount is, and it creates a UTXO with no inputs. And that's the only way a new UTXO can be created, and then this UTXO can be used as we had it in here. And Genesis block defined in the logic what is a Genesis block, the first ever created, and then every block following that follows the same rules about validity and can be verified by anyone who understands and knows the consensus, and it's open source. So you can verify yourself that this block is fine. And if there's a transaction in there that is verified, and if you are now C or D, for example, and you see this transaction in the block, you know you now have ownership of 10 coins in the UTXO, and you can create your own transaction, sign it, and do with that UTXO whatever you want. Send it to someone as long as you have a valid transaction, create a valid transaction, and it's included in the block by a miner. As soon as it's included in the block by a miner, it's verified and it's confirmed as a valid transaction. So last thing to quickly talk about, or to recap what's needed so that stuff on the blockchain is valid. Transaction is valid when it has a valid signature of every input owner. So everyone, all of the inputs need to be signed by the owner, that this is what should be done with the inputs. As I said, cryptography in there. Only valid inputs, so it needs to be unspent, no double spent or anything allowed. Inputs need to be UTXOs, previously UTXOs. And of course, the sum of inputs need to be bigger than the sum of outputs, so you are not allowed to spend more than you have. And the difference between the inputs and the outputs is the fee that you pay to the miner. There we have a bit of a topic that's likely better in a different video, but just to briefly talk about it, miners need to spend work, proof of work. Bitcoin is a proof of work chain, so they need to spend energy on finding such a block. To do that, they need an incentive. One incentive is the Coinbase, so that they create new coins. But just with the Coinbase, they would have the incentive to create empty blocks and don't care about transactions. So every transaction need to pay a small fee to the miner, so that the miner includes the transaction into the block. And that's the difference between the inputs and the outputs on a transaction, because the difference stays at the miner and they can keep that. Now a block is valid. So that's all to say about when a transaction is valid. Yes, there are also some other output types that don't create UTXOs, but have some scripts or something in there. But don't go overboard here. When is a block valid? It's valid if, on one hand, it needs to correctly reference to the previous block, because it's a blockchain. It needs to be clear, and the previous block hash needs to be included in the header of the block, so that it's a immutable chain of blocks, and this block depends on this block, so that no one can change contents of this block once it's deep in the chain. The hash block of the block fulfills the challenge. This is the proof of work part, because to create that, they basically need to solve a puzzle to find the block and fulfill that. This challenge is kept at the difficulty so that on average every 10 minutes a new block is found. That's the work of the miners. Again, different video. Leave a comment if you want to know more about proof of work, this challenge, difficulty and everything. But that's required to have a valid block. Of course, only valid transactions and a valid coin base. The coin base needs to be valid, and the sum of inputs needs to be bigger than the sum of outputs, plus the bait fee that goes to the miner. As I said, sum of inputs, that needs to be true on every transaction already, but this different fee that the miner sends to himself needs to be exactly this difference. Otherwise, they can't pay themselves more than they are allowed to. So that's all there is to verify that the Bitcoin blockchain is valid and all the transactions are fine there, and everyone can do that. So that's it. With that, you understand the basic building blocks of Bitcoin, of this currency. It's based on UTXOs, so unspent transaction outputs that are just following a directed acyclic graph through the network of transactions, and those transactions are just for verification and confirmation, basically put into blocks in the order that they are there. That's the only reason why we have blocks. Without the need for distribution in the network and having a way of not having random blocks coming or random transactions flowing around, so that we have a way of having one ledger where everyone is agreeing on the order and everything. That's why we need the blocks to have transactions ordered block by block. Otherwise, it would be enough to have just a directed acyclic graph of transactions. And that's it. Now you should know everything you need to know to understand how Bitcoin works. As I said, there are, of course, far more topics to dive into regarding the Bitcoin technology. I will try to do that in the next videos. If you have something that's on the top of your list of questions, leave a comment, tell me what you need, and I will try to make a video about that. I hope that helped. I hope that was understandable enough to give more insights and clear things up. And with that, see you in the next video.